Hello everybody, today I'm going to discuss about the delivery cost calculation problem using C++. If you want to read this question, please you can pause the video and read it, and then thereafter you can unpause to continue watching. So for the flowchart, we are going to say start. We are going to say enter the destination type. Then when the user enters, we are going to save it in our variable. Then we are going to display enter the package weight. When the user enters, we are going to save it in our variable. If the if the destination is equal to 1, then we are going to display 3000. Okay, but if not, we're going to check another condition. Okay, we're going to check else if the destination is 2. If that is true, there are two issues. If the destination is 2, check is the weight less than or equal to 5. If that is so, display 7000. However, if that is not so, it means the destination is 2, but the weight exceeds 5. So if that is the case, we need to display the summation of 7000 plus 500 times weight minus 5. Okay, take note of that. So let us try to implement that. So enter the destination type. We save that one. Enter the package weight. We save that one. If the destination is 1, we display 3000. If the destination is 2, we need to check. If the destination is 2, we need to check what is the weight. Is the weight less than or equal to 5? If that is the case, we need to display 7000. We need to display 7000. But if that is not the case, it means else, what do we want to do? We need to display this much here. We need to display, let me put brackets here, and let me put brackets here. We need to display this much, then the weight minus 5 times 500. All right, let's continue. Let's continue with our flowchart. If the weight was not 2, then we go to test another condition. Else if the weight is 3. So if true, not weight, destination. Okay, so if the destination was not 2, we go to test another condition. What if the destination was 3? So else if the destination was 3, then what was the weight? If the weight was 10 or below, we need to display 25,000. So if the destination is 3, check what is the weight. Is it 10 or less? If so, what do we want to do? We want to display 25,000. However, if the weight is not that much, else, it means the weight exceeds 10. So what happens if the weight exceeds 10? We need to display this much. 25,000. For every kilogram above 10, we multiply by 2,000. Okay, then let's proceed with our flowchart. What if the destination was not 3? It means the destination was not 1, it was not 2, and it was not 3. Then we know the user must have entered a destination which is not 1 or 2 or 3. In that case, we can just display an error message. So that was how our flowchart was. Okay, so start, enter destination, we save it, enter the package weight, we save it. If the destination is 1, display 3000. If not 1, else if the destination is 2, then is the weight 5 or less? If so, display 7000. If not so, then the weight exceeds 5, display this much. But if the destination was not 2, else if the destination was 3, then in that case, is the weight 10 or less? If so, display 25,000. Okay, and then if not so, display this much. Okay, display this much. Okay, all right. Okay, so you can see our program is going to run just perfectly. Our program will just be okay. Okay, enter the destination. So the user enters 3, enter the package weight. If he enters 10, 25,000. So you see our program is totally okay. And there is an alternative. Instead of using 1, 2, and 3, okay, within your program, instead of using 1 inside your program, 2 inside your program, 3 inside your program, you could define an enum, an enumerated data type. Okay, they are very good whenever you have your program that contains some special numbers. Whenever your program contains some special numbers, you are encouraged to use what we call enums, or in other words, we call them enumerated data types. So how do you use them? Okay, you can just declare an enum. Okay, so you can just say enum, and then you can call it, you can give it a name, maybe destination. Okay, then you define. So you say same city. We normally use capital to define enums. So you say same city. I want 1 to represent same city. Okay, and then you can say I want same country, same city within the same country. It will be represented by 2. So I don't need to write 2. The computer will figure out that the next one will be 2. Okay, and then you can say international. So it means international will now pick the number 3. You see? Yeah. So once you define this one, very simple. You see, when you come here, you see, when you come here now, it means now you're going to say, if the destination is, instead of writing 1, you just write same city. If the destination is same country, you see, you just write same country. And then here, instead of writing 3, you just write international. You see? Yeah. So your program will, instead of using those numbers, it now uses words. Okay, so it makes your program become more readable. Even when you come to your program 5 years from now, you will look here and you will see D, if D is equal to same city. So you know, if the destination was equal to the same city, else if the destination was equal to the same country, else if the destination was equal to international. So this is much more readable rather than using the number itself. Okay, so we call these enumerated data types, or for simple, we call them enums. Okay, we call them enums. So when you just write here, same city is equal to 1, it means same country will be 2 and international will be what? 3. And you can see the program will still work perfectly. Let me show you here. So you see, if I enter, the user will still enter 3. Okay, the user will not enter international, the user will enter 3. But you, inside your program, you know 3 is the word international. Okay, that is the magic of enumerated data types. So I enter here 3. Okay, then the package weight, I enter 10, and you see it still works great. Thank you for listening. Keep it up. I know there are many other ways of doing this same program, and there are many other ways of drawing this flowchart. So feel free to play around with different other alternatives. Thank you for listening. I wish you guys all the best.